Hello and welcome guys. In this tutorial we will be looking at visualizing univariate and multivariate distributions. So since we started with matplotlib, in this tutorial we will be using Seaborn library for data visualization purpose. So basically Seaborn is built on top of matplotlib and it creates more attractive plot than matplotlib. So it will be for more concise, and we can make so many customization in Seaborn. So that's why we will be using in Seaborn for visualizing univariate distributions. Okay, so let's start. So whoever working with Seaborn for the first time, again they have to install pip install Seaborn like I showed for matplotlib. Okay, so since I already installed, it will say like requirement satisfied. Okay, now I'll be importing all the data. So since we basically visualize univariate distribution before using box plot and then histogram plot, let's do the same thing using Seaborn, and we'll see the difference between both of them. Okay, let's copy from top. Okay, so we have imported matplotlib also. Now we have to import Seaborn also. Okay, so we are done with importing part. Now we'll take that market fact data that we imported few days back. Okay, yeah, this one. So we'll use this data for doing the univariate distribution plots. So before that, there is something called sns.setStyle. So basically I want my style of my plot should be wide grid. Okay, if you don't do this, it will be blank, and if you want grids to be included to your distribution or any type of plot, you will write set style. And there is so many other type of styles that you can use. For now I am using wide grid. Okay, now basically we will be seeing histogram and density plot here. So basically this histogram and density plot, so basically histogram and density plot basically shows the frequency of a numeric value along with the y-axis and the value of x-axis. Okay, and for Seaborn it is called using DIST plot, distribution plot, and it will be more attractive, or more eye-catching than matplotlib. So let's plot it. Okay, sns dot dist plot. Now we will have to pass the column name, which was shipping cost. Now do you see the difference? I mean, this chart is more good graphics than we were looking at this one, right? So this is how the difference is in between matplotlib and the Seaborn, and that's why people use Seaborn over matplotlib, because it's an update of, basically, like I said, it is a build on top of matplotlib, so that's why it is like a second update for matplotlib. So let's do another things also. So let's say you want to skip the bars from the distribution plot. So that time what you will do, you will copy this, you will make hist equal to false. Okay, because you just want to see the curves that you that we see here with the dark blue color. And again, so that this is how you will be working with distribution plot, because you can make customization here. You don't want to see the bars, is it that is okay, you can make it by using histogram equal to false, which is hist equal to false. Now let's say you want to see bars, or you can say rug. So if you search what is rug plot, it will tell you basically it basically shows the bars in the charts, which is in the block. Okay, so let me show you. Yeah, the red blocks that you see here, they are called rug basically. Okay, and this also like means degree or something. I have to check it. So let's see this. Okay, so if I make rug equal to true, it will show me those rugs that we just see here. Okay, as you can see now, we have it has added those rugs here. Okay, to see, or you can say whenever we see stock market charts, you can see in the bottom we can add volume, and volume exactly I mean we see it like this only, right? And that's why there we use rug equal to true. And now we'll see subplots. Okay, so like we did in the same way we will be doing for Seaborn. So let's pick up this one. Okay, just copy this whole code and paste it here. Instead of plot, we will write dist plot. Now this plot. Now we don't need figures because Seaborn automatically identify it. Now we have to change X with this one. Okay, I'm not changing the title, let it be like that. Okay, matplotlib, it doesn't have distribution plot. So, okay, we have to write SNS. So ignore the warnings. So as you can see, why we are seeing just two plots. Okay, here I think we have to explicitly mention how many columns and how many row we want at first. Okay, so we want 2 rows and 2 columns. Okay, and that's why we have written 2 row 2 column 2 row 2 column 2 row 2 column. Now the number of slide. I mean, or you can say figure. So 1 2 and this one will be 3 and this one will be 4. Okay, so basically number of figure. Now if I run this, I think it will get fixed. Oh, now you can see, right? I mean 4 plots. So this is how you will be working with C1. So basically you can see that it is more easier to mention subplots, I mean numbers here, because earlier it was we have to mention like what is a row, what is a column, and then 1 2 1 2 we have to repeat. But here it is more clear that we just have to first mention how many row we want, how many column we want, and then you can just number it. Okay, now let's work with box plot. Okay, so it's the same way we have done. We'll just copy that code. I don't know why my laptop is hanging. Okay, so this one, yeah, so just copy that code and then we'll paste here, but here it will be sns dot box plot. Now you'll see. Okay, now you can see, I mean the box plot is not much attractive but similar to matplotlib. Okay, so now we have seen all the examples that we have done in matplotlib, and we have done it for all the plots. Now we will move to multivariate distribution plot. Okay, so multivariate distribution plot or any type of plot basically help us understand the relationship between two features. Basically they can be assigned to x-axis and then y-axis, and they help you see the relationship between them. Okay, so first of all let's start by joint plot. Okay, there is something called joint plot. We used to see the profit and sales between them. Okay, and how the relationship is basically we see in data. Okay, so what we do, sns dot joint plot, and then we have to pass x and y. So our x will be sales and y will be profit. Okay, now you have to pass one more thing, that is what is your data frame. Okay, so our data frame is what we named it, oh yeah, df. Okay, now we have to pass df. Now we have to plot it, so plt dot show. Okay, it's saying take from 0 to 1 position argument, but 3 is given. Okay, so basically I think we have to explicitly mention what is our x and what is our y, and that's why the error is basically throwing. So let's do that. Okay, it's what saying again. Okay, let's do that. Okay, so now you can see it has returned us a joint plot between sales and profit. Now you can estimate that the distribution is heavily skewed and all the points seems to be concatenated in one region only, this region, particular region, and this is because some of the extreme value of profit and sales which matplotlib is trying to accommodate is limited to that particular space. But you can see the space in here is very high, and you can see that where exactly I mean basically the data is skewed. So here also you can see, right, like a distribution plot. You can see here the data is skewed towards here only. Okay, most of all the data. So let's remove those extreme values, those are here. Okay, and this also, to see what exactly our data tells us. Okay, so to do that, let's create one more data frame out of existing data frame, where I will tell my data frame profit should be how much, less than, let's say 10,000. Okay, and what I want, my sales should be, again the same thing, my sales should be less than 20,000. Sales should be less than 20,000. Okay, now we'll plot this this data frame and we'll see the difference. Okay, just copy this one, replace the data frame. That's all you have to do. Now you can clearly see the difference between matplotlib and seaborn's joint plot, because you have made some customization, and now you can see the profit and the sales more clearly. Okay, and now you can see the distribution has also changed. Okay, because we are like it's like zooming inside our data set, so we are zooming here and seeing what is the distribution here. Okay, so this is what and also there is one thing, I mean, we can adjust the arguments of the joint plot. There is one joint plot also which will make the plot is more readable. Okay, for example, specifying the type of plot that we want to see, but not here but in joint plot. So let's see the example. So we'll have the same data frame that we are using, but we'll basically limit our data frame towards like sales value. Okay, or sales and profit value. So df2 equal to, since df1 is already defined, we'll create one more, that is df2. Let's copy this, and I want my profit value should be less than 100 and my profit less than 100 and greater than minus 100. Okay, because we have some value in negatives also. Now we will also filter sales value. Okay, so sales, let's say less than 200. Now we have our data set ready. Now we'll apply joint plot. Okay, since we have to explicitly mention x and y, so let's see x equal to sales, y equal to profit. Our data will be df1, okay, df2. Okay, now we want you can also like mention color here, like color equal to red, green, blue, whatever you want to give. For now I am giving G for green. Okay, now we'll see it. Now you can see the color has been green, and the distribution as well as a histogram we can see here, right? I mean the distribution, basically including distribution, we can see how the data has been distributed now. But in this chart we were not able to see, as well as not in matplotlib, but using joint plot we can see two different plot in a same plot. Okay, so you can see scatter plot also, we can see histogram plot also. So let's see how many more parameter we have for joint plots. Okay, so you will type shift tab. Now we'll see so seaborn documentation is more clear than matplotlib. Now you can see all the parameters: hue, kind, height, ratio, space, drop, and let's try out kind. Okay, so we have what is kind, so it is kind of plot to draw. Okay, so we have hex, hist, kd, scatter. Okay, let's try one. Let's try a hex and kd. Wow, so this is more more informative. We can see our where our extreme value lies. I mean extreme means where the most of the distribution is lying towards this point, because we can see, I mean the color is so dark. Okay, and you can see the extreme value are getting the color are fading away, and from that we can say that so the I mean the sales or you can say profit basically are directly proportional to each other. Okay, so let's say KD1. Now KD is like a hue, I mean a box where so much informative, right? I mean you can say instead of histogram you can say the line, how the value is distributed. Same here, and you can see the depthness of value distributed across all over the plot, or you can say variation or spread across the chart. And this is also like more informative and more attractive also. Now let's see an example of pair plots. So pair plot basically compare all the numerical value, all the numerical feature we have in our data frame. Okay, so let's plot it. So what you will do, sns dot pair plot, and we just have to pass our data frame. Okay, now you will see comparison between each of the charts, or you can say features, and you will charts for all of them. Okay, so it takes a little bit time because we have multiple feature, and then for all the feature it does that. Now you can see all in one. I mean, whatever you wanted to do, you can do using pair plot. I mean, and you can compare the sales with discount, order quantity, profit. So all these are that only. I mean, discount, order quantity, and you can see how the data is distributed across all the features. And so to make sense, if you want to compare one feature with another feature, there is another plot also, that is called heat map. Okay, heat map is a like it will tell you the relationship between one feature with another feature. Okay, so let's plot that as well. Okay, so first of all we need to find the correlation in between all the column that we have. So, and remember that all this can be possible for all the numerical value that we have, not for categorical value. Okay, because categorical, if you even encode the categorical to numerical, it will won't going to make any sense. Okay, you can make sense of sense out of it, like comparing regions, number of region in each country have I mean sales they have done. So those type of thing you can do, but obviously categorical columns are not meant for this type of thing. Okay, so let's do heat map. Okay, so for that first you have to find out correlation. So finding correlation is so easy. So correlation basically tells what is a relation, what is a correlation coefficient in between value x and value y. Okay, so let's find the value. Okay, so to find the correlation we just have to write df dot corr. Okay, and it will give you the correlation coefficient value, and I want to make them round figure. Okay, rounded by 3, I mean 3 decimal point. Okay, so now store it inside core 1. Okay, now let's see what is inside core 1. So you can see now between sales and sales, obviously it will be like 100% correlation. Now let's say I want to see sales with discount. You can see the correlation is in negative. Okay, so the correlation can be either negative or positive. Negative doesn't mean that that particular feature is not important. You can say it as it is negatively opposite, like negatively related to sales. Okay, so increase in sale will decrease in discount, or you can say decrease in discount will increase in sale. That way you can convey such messages. Now you can see sales has positive correlation between profit. You can see 58% like correlation. Okay, so just ignore the 0 here. Basically it's in percentage only. So after dot, whatever number you see, that is your percentage. Okay, so here you can see 58% positive correlation. So what I mean by that is, if sales is increasing, profit will also increase, that way. Okay, and wherever you see negative value, wherever sales will increase, discount will decrease, or vice versa, like that you can understand. Okay, now let's plot the heat map. So how we do it? Basically for heat map we have to like set size of our figure, because by default Seaborn or Matplotlib basically creates small plots like that. We have seen on top examples, but they have also provided one functionality where you can set your figure size your own, like based on your requirement. So we'll do that first. Fig dot plt dot fig size, and sorry, figure, and inside that you will mention figure fig size, and it's like a ratio. So 10 by 8. Okay, so it's like a 10 vertically, sorry, 10 horizontally, 8 vertically. Okay, so like that you can mention, and then we have mentioned this is the size we want. So obviously as you can see, 100 means 1000 pixel, 8 mean 800 pixel. So you can take it as a power of 2. Okay, now let's plot it. Okay, sns dot heat map, and you have to pass the data, that is our corr1. And now there is 2 more parameter which is important. I will show you after this. So if you plot this way, you can see it has like all the numerical value on x-axis and y-axis, and it will show how much the value is correlated. Okay, now there is one more there is two most important a variable that you can pass. First is annotation. Okay, so if you want annotation to be inside this square box, you have to make it true. So annote equal to true. So now inside that you can see the correlation coefficient value. Okay, now there is another parameter, that is color map. So because since sometime the type of color map you choose, obviously it will not going to suit your requirement. So that time what you do, you change the color map. So I don't remember any color map, but I can take help from help. Okay, so what all color map they have basically. So let's see, any they have not mentioned any color map, and shift tab is also not working, I guess. Okay, so we'll take an example from their documentation. So we can say heat map. So you can check as many as possible. uh, so they have so many, you know, combinations of, you know, color map that you can use from. So where is C map? As you can see, they have so many different colors that they have used for given examples. Okay, let's use spectral, see how does it look like. So you can see it has been changed based on spectral, whatever the color mapping has been done for spectral, you can see here. And this is how you will be using different parameter of seaborne to see how heat map I mean showing us a correlation between different numerical values. So that's all for this tutorial. We'll see you in next. Thank you. Just wanted to add one more point, that is to recap. Basically in bivariate distribution you have like two variables which interact with each other. You are looking at the combination and you know, you see the, you know, association or, you know, between them, and you see how they are related to each other. Okay, that is what we do in bivariate distribution. And the other thing that we have seen here is the, you know, heat map. So basically this is a way, I mean, quantifying the relationship between two variables, and their value lies between -1 to 1. Okay, and a correlation value of 1 basically means that in between x column and y column, which means x or y feature, they are perfectly linearly related, and when x goes up or down, y follow the same direction. Okay, so this you can take it as a example of what we have done here in heat map. So I have also gave you an example between sales and sales, and then sales discount. So increase in sales, decrease in discount, that way you will be basically conveying some messages, not just based on this, but you will do similar type of other analysis also. Also like heat map also useful because they help you identify areas of, you know, high and low value easily, like we just seen here. Okay, and you know, in this example we can spot where the high correlated value lies. I mean in between which values. So sales and profit, we can see around, you know, 60% positive correlation coefficient. So, and then shipping cost and sales also. Oh sorry, yeah, shipping cost and sales, shipping cost and discount is very less, shipping cost and product based margin. So this type of, you know, messages you can convey that we have positive correlation between these feature and negative correlation between these feature. Okay, but ignore the diagonal is like comparing the correlation between same features. Yeah, so that's the point I wanted to add. Thanks for watching again.